In this video, I'm going to introduce Solidity. Solidity is currently the main programming language for Ethereum. Up until this point of the series, I've been talking about how blockchain works. Now I'm going to move into more practical solutions and share how you can create and manage blockchain networks. Solidity is an object-oriented, high-level language for implementing smart contracts. Sometimes it's referred to as a contract-oriented language. Smart contracts are programs which specify behavior of accounts within the Ethereum state. It is an open source language that was created by the Ethereum core contributors. The language was influenced by C++, Python, and JavaScript, and it is designed to target the Ethereum virtual machine, or EVM for short. The EVM is the runtime environment for smart contracts in Ethereum. It is not only sandbox, but actually completely isolated, which means that the code running inside the EVM has no access to the network, file system, or other processes running. Smart contracts even have limited access to other smart contracts. Solidity is statically typed, meaning that the type of a variable is known at compile time instead of at runtime. Solidity supports inheritance, libraries, and complex user-defined types. Now I'll head over to the Solidity website to take a look at the primary structures that make up a smart contract. Here you can find lots of information about how to get started with Solidity. To visit the Solidity website, you can head to solidity.readthedocs.io. Here you'll be taken to the Solidity homepage. Right off the bat, I can see lots of helpful information about the language, and I definitely recommend this as a resource for getting started with just knowing more about the language. For the purposes of this video, I will focus on the section, a structure of a contract. And I want to take a moment just to explain the primary structure that you'll see in a typical smart contract and talk through each of these. So first step, you would have state variables. State variables are going to be used in every single contract, and they're going to help store some kind of value. A typical type that you'll see is an integer. So here you see an unsigned integer represented as uint. You can also have signed integers, which are represented as int. Then there are functions. Every contract will typically have some kind of functions. Functions are executable units of code and can be defined inside a contract, but also can be defined out of a contract. Functions in Solidity are similar to other functions and other programming languages if you're familiar with that. Like, so if you're familiar with functions in JavaScript or C++, for example, this might be very familiar to you. And typically you'll have a function that will do one action that you're describing. There are also function modifiers. Function modifiers are interesting because they limit who can basically call and interact with this function. So if you look at this example, and here we have a function called abort with this modifier only seller. This modifier only seller is defined up here, and it requires that only the seller can be able to call this abort function. And next we have events. Events are really a key part to smart contracts. With events, these are going to log directly to the EVM, the Ethereum virtual machine, about activity that's happening within the contract. So to define an event, I can do this here using the syntax event with a name as well as different parameters. And then when I want to call the event, I use this emit keyword with the event name. Then next are struct types. Structs are an example of a custom defined type that group separate information together. So in this example here, we have a struct voter, and there'll be different attributes about that voter. So weight, whether or not they voted, the address, which is going to identify that voter, and then an integer, an unsigned integer, vote. So all of these related items basically make up this struct of a voter. And then there are enum types. So enums are another custom type that you can define. And basically what you're doing here is listing all of the possibilities that can be happening with this particular enumeration. So if you look at this example, we have an enum state, and we're going to list out all the possible states, which are created, locked, and inactive. So that's pretty much what you need to get started with Solidity, and these are the primary structures that you're going to be using in Solidity contracts.